Jam berapa sekarang? Sekarang 9.18. Jangan boleh kurang. Ya, siap. Kamu juga jam. Kamu juga udah ditambah mana? Ya sampai 1.5.
Assalamualaikum warahmatullahi wabarakatuh. Now I will deliver my presentation about energy transfer. Energy is a term that pervades all branches of science. It links a wide range of phenomena and enables us to explain. Nggak mau lah. Explain them. It exists in different forms, and when something happens, it is likely to be due to energy being. Apa? Assalamualaikum warahmatullahi wabarakatuh. Now I will deliver my presentation about energy transfer. So energy is a term that pervades all branches of science. It links a wide range of phenomena and enables us to explain them. It exists in different forms, and when something happens, it is likely to be due to energy being transferred from one form to another. Energy transfer is needed to enable people, computers, machines, and other devices to work and to enable process and change to occur. For example, the water skier can only be pulled along by the boat if there is energy transfer in its engine from the burning petrol to its rod. And next, I will explain about forms of energy. So for the first is chemical energy. Chemical energy is like a food and fuels such as oil, gas, coal, and wood are concentrated of chemical energy. The energy of food is released by chemical reaction in our body, and during the transfer to another forms, we are able to do useful jobs or activity. Fuels cause energy transfer when they are burned in an engine or a boiler. Better are compact source of chemical energy, which in use is transferred to electrical energy. And for the second is potential energy, or PE. Potential energy, this is the energy a body has because of its position or condition. A body above the earth surface, like a water in a mountain reservoir, has potential energy, or PE, stored in the form of gravitational potential energy. Work has to be done to compress or starch a spring or elastic material. Energy is transferred to potential energy. The PE is stored in the form of strain energy or elastic potential energy. If the catapult, if the in the example, there is a water in a mountain reservoir, so the energy stored in the form of gravitational potential energy. And for the second the second example is people is stretching of the catapult, so the energy stored in the form of strain energy. And then I will explain about kinetic energy, or KE. Kinetic energy is any moving body has a kinetic energy, and the faster it moves, the more KE it has. As like this, a hammer drive into Nile, drives a Nile into the pitch of wood. There is a transfer of energy from the key of the moving hammer to other forms of energy. So the difference from potential energy and kinetic energy is if potential energy is position or condition, but for the kinetic energy is any moving body and the faster move. The fourth is electrical energy. Electrical energy is produced by energy transfer at power station and in battery. It is the common form of energy used in homes and industry because of the ease of transmission and transfer to another form. And the electrical energy is produced by energy transfer, usually in battery and the power station, and usually used in home and in industry. For the heat energy. Heat energy, this is also called the thermal or internal energy and is the final fate of other forms of energy. It is transferred by conduction, convection, and or radiation. The meaning of the conduction is the transfer of energy in the form of heat or electricity from one of atom to another within an object by direct contact. The conduction of heat occurs when molecules increase in temperature. They vibrate, and this vibration and movement pass the heat energy to the surrounding molecule. And for the second is convection. Convection is the transfer of heat through a stream through which intermediates are transferred. If the particle move and cause to heat propagate, convection occurs. Convection occurs in liquids and gas, or air or wind. So the difference between conduction and convection is conduction uh, by direct contact, but convection is intermediates are transferred. And next is radiation. Radiation is heat transfer without intermediates is radiation, and radiation is heat transfer without an intermediate again. Like the sun, heat reaches the earth even though it is through a vacuum. And the difference between convection and radiation is convection use intermediates transfer, but radiation is use intermediate. For the example conduction, for the first is burn the iron tip. The tip of the iron that is not hot will become hot. And for the second is ironing clothes. If you when do ironing clothes, you ironing clothes will be feel hot. And for the third is ice cubes that melt when held due to warm body temperature move to the ice. And for the convection, the example is heat transfer, namely the occurs of land and sea winds when heat water will boil evenly. The smoke in the chimney will move up. The movement that occur that hot air balloons and the up and down movement of soybeans when heat. And for the example of radiation is if the sun heat reach The Earth is a clear example of this form of radiant heat transfer, even though the distance between the Sun and the Earth is very far and spared by a vacuum. The sun heat can still reach the Earth through rays. So, uh, the distance sun to the earth is so far, but the sun can still reach the earth through rays. And next, this is about demonstration. Um, can be used to solve a battery. Use a battery. Change changing chemical energy and to the electrical energy which become kinetic energy in the motor. The motor rise away, giving it potential energy. If the chain of a switch is joined to the lamp and the wake allowed to fall, the motor acts as a generator in which there is an energy transfer from kinetic energy to electrical energy. When this is supplied to the lamp, it produces transfer to heat and light energy. And next is energy measurement. This purpose is work. Work in daily life is like do homework, do job, but in physics is work has a different meaning from its everyday use. Work is done when a force moves. So the work in daily life and this physics is little bit different because in daily life work is like do something, but for work in physics is like a force move. Now, work is done in the scientific sense by someone standing still holding a heavy pile of books, and upward force is exerted, but no motion result. If a building worker carries then brick up to the first floor of a building, he does more work than if he carries only one brick because he has to exert a large force. Even more work is required if he carries the 10 bricks to the second floor. The amount of work done depends on the size of the force applied and the distance it moves. We therefore measure work by and work is equal to work times distance moved in direction of work. This is in the form. I will repeat again. Work is equal to force times distance moved in direction of force. And this is measuring energy transfer. In measuring energy transfer, in an energy transfer, work is done. The work done is a measure of the amount of energy transfer. So the difference between work and measured energy transfer is work is force move. Work is done when a force move, but measuring energy transfer is a work is done. And next it is power. Power in daily life is like the people can bring many floor or many book, but in physics also same. In physics, power is the amount of energy transfer or convert per unit time. In the international system of unit, the unit of power is the watt. Power is the watt, so equal to 1 joule per second. In older works, power is sometimes called activity. Power is a scalar quantity. Power is a measure of energy transfer rate. It is useful to talk about the rate of which energy is transferred from one system to another, or energy per time. This rate is called power. 1 joule of energy transferred in 1 second is called a watt. E, i.e., 1 joule per second is equal to 1 watt. And next, this is about energy conservation. So the first is principle of conservation of energy. This energy cannot be created or destroyed. It is always conserved. Energy is continually being transferred from one form to another form. So this is one of the basic laws of physics and is stated as follows. Energy cannot be created or destroyed. It is always conserved. However, energy is continually being transferred from one form to another form. Some forms, such as electrical and chemical energy, are more easily transferred than another, such as heat, for which it is hard to arrange a useful transfer. Ultimately, all energy transfer result in the surroundings being heat as a result of doing work against friction, and the energy is both, i.e., spread out and increasingly more difficult to use. For example, is when a brick falls, its potential energy become kinetic energy. So when a brick falls, its potential energy become a kinetic energy. As it hits the ground, its temperatures and heat and sound are produced. If it seems in a transfer that some energy has disappeared, the lost energy is often converted into non-useful heat. This appears to be the fate of all energy in the universe and is one reason why new sources of useful energy have to be developed. And this is efficiency of energy transfer. So efficiency of energy transfer is to reduce the amount of energy need. So the example is like a turn off the light when it is not in use, and like the another object electricity, if you didn't use again, you must turn off the object, because efficiency of energy transfer is to reduce the amount of energy need. And for the next is energy of food. Energy of food is energy value of a food substance is the amount of energy released when 1 kilogram is completely oxide. Energy value is measured in joule over kilogram. The energy value of some foods are given in megajoules per kilogram. Foods with high value are fattening, and if more food is eaten than the body really needs, the extra is stored as fat. The average adult requires about 10 megajoules per day. Our muscle change chemical energy into mechanical energy when we exert a force to lift a weight. For example, is Unfortunately, they are not very good at doing this. Of every 100 joule of chemical energy they use, they can convert only 25 joule into mechanical energy. That is, they are only 25% as efficient at changing chemical energy into mechanical energy. The other 75 joule become thermal energy, much of which nobody gets rid of by switching. So if just 100 joule from the mechanical energy, just 25 joule, because I think 100 joule divided uh, 4 is equal to 25 joule into mechanical energy, and just there are only 25 efficient at changing chemical energy into mechanical energy. And next, this is about combustion of fuels. Fuels can be solid, such as wood and coal, liquids such as fuel oil and paraffin, or gases such as methane and butane. Some fuels are better than others for certain jobs. For the example, is fuels for cooking or keeping us warm salt, as well as being cheap, have a high heating value. This means that every gram of fuel salt produces a large amount of heat energy when burned. So, like this a firewood. Firewood is the burn to become firewood burn, and the burn of firewood can be used to cooking, keep of the body warm, and other. And the price of in a price of firewood is cheap, and but firewood has a high heat value. And next, Daniel Halliday. Daniel Halliday is as the founder of Windmill, and he birthed on 24 November 1829 in Marlboro, Vermont, America, and he was died March 1, 1916 in Santa Ana, California, America. And Daniel Halliday as American nationality. So the earliest known wind-powered grand mills and water pumps were used by the Persians in AD 500 until 900, and by the Chinese in AD 1200. The first windmill manufactured in the United States was designed by Daniel Halliday, who began inventing windmills in 1850 in his Connecticut machine shop. And next, this is the picture of windmill. Windmill is a depend with wind, and then the propeller will spin and generate electrical energy, and the electrical energy and can use to like fan, television, radio, lamp, a washing machine, computer, and other. This windmill is a energy transfer because it has energy from wind and to be changed electrical energy. So the energy transfer from windmill is from wind surge to change to become electrical energy. And next, um, Pillow Philo Farnsworth, Farnsworth and John Logie Bart as the founder of television. So for the first I will tell the biography of Philo Farnsworth. Philo Tyler Farnsworth, he born on wa- eh, 19 August 1906 in Beaver, Utah, America, and he was died on 11 March 1971 in city of Salt Lake, Utah, USA. And Philo Farnsworth is a national American. Philo Taylor Farnsworth is an American inventor who is remembered for inventing the first perfect electronic television system, including an electronic image reception device. And next is John Logie Bart. John Legibert is on 13 August 1888 in Helensburgh, United Kingdom, and he was died on 14 June 1946 in Big Hill, United Kingdom. And John Logibert as a nationality of Scottish. John Logibert is the inventor who first saw that moving visual image can be transmitted on a television set. He is also known as a major pioneer in the history of the invention of color television until he was 35 years old, but lived in condition of complete deprivation. So the different below Frankfurt and John Logibert is below Frankfurt is image reception device electronic, and but John Logibert is uh, so that moving visual image can be transmitted on a television set. Television also as energy transfer because television from the electrical source to become like a visual picture, sound, sound, sound energy. And now the electronic of object has been sophisticated like television and nearly just from cable. The television will can sound the picture, video, and sound. So the energy transfer of the television is from electrical energy to change to become sound energy and picture energy or visual energy. And next, Guglielmo Marconi. Guglielmo Marconi is the founder of radio, and Guglielmo Marconi birth on 25 April 1874 in Marescalchi Palace, Bologna, Italy, and he was died on 20 July 1937 in Rome, Italy. And the full name of Guglielmo Marconi is Guglielmo Giovanni Maria Marconi. And Guglielmo Giovanni Maria Marconi as a nationality of Italian Kingdom of Italy. Guglielmo Marconi is an Italian electrical engineer and Nobel Prize winner, best known for develop a wireless telegraphy system known as radio. He received it with Carl Brown in 1909. So for at the time radio famous, the name is wireless telegraphy system, but now the name is radio. I think radio now didn't famous in the millennial people uh, because now has been there are many electronic more sophisticated than radio, and radio I think just little bit people use radio. So the transfer energy in radio is from electrical energy change to become sound energy. And next, uh, Edmond Bequeler has become the founder of solar panel. The Edmond Bequeler birth on 24 March 1820 in Paris, France, and he was dead May 1891 in Paris, France, and Edmond Bequeler as a nationality of France. The full name of Edmond Bequeler is Alexander Edmond Bequeler, known as Edmond Bequeler, was a French physicist who studied the solar spectrum, mechanism, electrical, and optics. He is credited with discovering the photovoltaic effect, the principle of operation of solar cells, in 1839. And this is a solar panel. Solar panel is a device consisting of solar cells that convert light into electricity. They are called the sun over the sun or so because the sun is the strongest light source that can be utilized. Solar panels are often called photovoltaic cells. Photovoltaic can be interpreted as like electricity. So the solar panel depend of the light of like source of sun, and the light source is become like electricity. And next, this is a camper van use solar panel. Camper van is like luxury car because the design of camper van such as in home. In camper van there are like a bedroom, kitchen, bathroom, and another room. Usually car use fuel, but for this camper van use a solar panel. Solar panel didn't just can help people in home, but the solar panel can also help people to drive a cars, and the benefits use solar panel it is didn't spend many fuel, and the energy transfer is from like source to become electrical energy. So Energy transfer of solar panel is from the light source sun to change to become electrical source. And now I will tell you about the example. The example. Ada Pak, itunya gimana? Yang buat bikin itu. Yang kayak gini.
Masuk dulu sini, enable editing dulu ini.
This for example of work. The work. So example calculating of the work. So this the form is joule is equal to Newton Newton times meters like this. And for the example is if I have 50 Newton, this as a newtons, and has 3 meter as a meters. So how much the joule? So you can count this. Joule is equal to 50 times 3 is equal to 150 joule. And so the form of work is joule is equal to newtons times meters. And the example is 50 Newton. 50 Newton is as a newtons and 3 meter as a meter. So how much the joule? Joule is equal to newtons times meters, and 50 times 3 is equal to 150 joule. And then next I will give you the example from the work. The work done is a measure of the amount of energy transfer. The form same like work. If I has a force is equal to 10 Newton, and the vertical distance is equal to 1.5 meter. And how much the work done? So the work done is of 10 Newton. Aduh. Times, I'm sorry, wait, 3 meters to 1, and this 10 Newton times 1.5 meter is equal to 15 joule. And for the power, the form of a power is watt is equal to joule times second. And if I has the example, if the joule is 500 joules and the second is 10 second, 10 second is 10 second as a time, and what how much the watt, so you can what like this, watt is equal to 5 I'm sorry, this wrong, this joule divide as so 500 divide 10 is equal to 50 watt. And I will give again the example. If you still confused, I will give again the example. For the work, I will remember you again. Work in physics is little bit different from work in daily life, because work in daily life like do something job, something like your homework, this is work. But the work in physics is done when a force move. So we'll remember you again the form of work. So work is equal to force times distance move in direction of force. This the basic form of work is force time distance move in direction of force. I will use make again the example. So if I have 700 joule and I'm sorry, this is not joule but this Newton. This is a Newton and I have what 5 I think 5 meter. So how much the joule? So joule is equal to 700 newtons times 5 meters equal to 350. Wait 3,500 joule. Oh yeah, and I will give you again selama give you again the this is when the force is equal to 25 newton and the vertical distance is equal to 3 meter. So how much the work done? So you can calculate like this: 25 newton times 3 meter is equal to 125 joule. And then I will give you again the example of power. If I have 240 joule and I have the 6 second is second as a time. So how much the watt is equal to joule divide second. So is equal to what? Is equal to 240 divide 6 is equal to 40 watt. and I will explain you again if you still confused about the different potential energy and kinetic energy. So I will tell you again the potential energy. This is the energy a body has because of its position or condition. So the potential energy is uh, has because of its position or condition. And this is a kinetic energy. The difference from potential energy and kinetic energy is a kinetic energy is any moving body has kinetic energy, and the faster it moves, like the example, the hammer pulls to nail into the piece of wood, and in there is a transfer energy. Berapa menit kok? And this the firewall press the firewall press is a cheap because but firewall is has a high heat value and has many benefits from in our life, like you can cooking, use fiber, you can keep of the body warm, use fiber, and yeah, many benefit from the combustion of fuels of fiber. Apa udah sejam? Udah belum sih? Pak Zainal?
9 menit lagi. 9 menit.
Oh, 9 menit lagi. Enggak. Kurang berapa jam? Kurang berapa menit?
Kurang 9.
Ya. Ya. Yeah, I will tell the solar panel. So now there are many countries use solar panel to because the solar panel is easily to use, and the price of solar panel is, I think, cheap, and there are many, and this is amazing because from the like source can to become the electrical energy, like you can use the air conditioner with solar panel, and use computer, use electrical another, like a fan, like a washing machine, like to charge your handphone. And yeah, there are many benefit from solar panel. I will tell again this windmill. The first country use windmill, I think, in Belanda, because in there there are many people use windmill to use the wind energy to become electric energy. And windmill seem like a solar panel because but the different windmill use a wind source, the but the solar panel use like source of the sun. and and then uh I will I will explain again the example from the conduction, convection, and radiation. The example from conduction is for the first I have 5 new examples. For the first is burn the iron tip. The tip of the iron that is not hot will become hot. And for the second is ironing clothes, and your clothes will feel hot, I think. And the third is ice cubes that melt when held due to warm body temperature move to the ice. And for the fourth is the plate gets hot when the hot food is placed. And for the last is hot engine exhaust when the engine is start. And the example from convection is namely the occurrence of land and sea winds. When heat water will boil evenly, the smoke in the chimney will move up, and the movement that occur in hot air balloons and the up and down movement of soybeans when heat. And the example from radiation is the light from the sun. The distance from sun to the earth is long. I don't know the distance, how much distance, because I know this long. And but the light of sun can the light of sun can still reach the earth through rays. So the difference from conduction, convection, radiation is condition. Convection and radiation is conduction is the transfer by direct contact, and the convection use it didn't use intermediate transfer, but for the radiation use intermediate transfer. And I forget to tell about the other forms. So the other form in energy transfer is some device has been invented to cause particular energy transfer. For example, is a microphone change sound energy into electrical energy, and a loudspeaker does the reverse. Bells, chimes, or gears are used to transfer energy between moving. So the example from other from is I just saw the two microphone and loudspeaker, because microphone change sound energy, microphone change to energy to become electrical energy, and loudspeaker does the reserve. Bells, chants, or cheers are used to transfer energy between moving. Electrical energy. So electrical energy is like produced by energy transfer. Usually there is in battery and in power station. and usually people in home and industry need a battery and power station. And then udah belum 14. Bentar. Kurang apa enggak? Udah 10.19 sekarang. Udah ya Pak? Tinggal tanya jawab. Udah. So I think enough for me. Any question please?
Sakit.
Sakit. Ya.
Aku baru sakit.
Bare
Iya
Ratna.
sakit. Iya sakit. Iya sakit.
Bare Ratna.
Iya sakit.
Aku habis Rizal.
What is the example of things that can radiation?
Wait. Radiation is like this. If there is a firewood and your hand, what is approach of the firewood, your hand we can feel hot. That the thing is a firewood.
Thank you.
Ya,
Aku Zal, aku.
ya Ratna.
How we can know that our potential energy and kinetic energy.
Wait.
Okay.
The potential energy, it is a position or condition, but for the kinetic energy, it is a unmoving body and a faster move, like that.
Okay, thank you.
Ya,
Rizal.
iya. Ya, what? Jal.
Yeah, okay. Sorry.
Yeah.
I think in chemistry and physics there is an energy. I want to ask you, what difference is general about chemical energy and physical energy?
Physical energy.
Yeah, what different?
Chemical energy is like energy kimia. It's like wait. I'll
Zal, don't forget to open message.
ya later. So chemical energy is energy produced by stable chemical compounds due to the interaction of electron between atom or between molecule. And for the physics of energy, like you do exercise, because this is a physics, yeah, like that.
Yeah, thank you.
Yeah,
Zal.
yeah. What? Hai. What, Nai?
Of
Apa? Apa? What? Give me two example from condition of heat. So for the first example is burn the iron tip, and for the second is hot engine exhaust when the engine is start. like that. Next, like that.
Kaila, Zal, Kaila.
Ini Faisal.
Kayla.
Yes. Oh. What is the most used energy?
What? Please
What is
louder.
what is the most used energy?
The most.
Yes.
I think America, because America is like what is uh um because America has been produced many like electrical sophisticated. I think America is a country the most of use energy. Next.
Okay, thank
Okay,
you.
Faisal.
Yeah.
From conduction, convection, and radiation, which one is faster to transfer the energy, and what is the reason? Thank you.
I think in the what the question? I forget.
From conduction, convection, and radiation, which one is faster to transfer the energy, and what is the reason?
Oh, the faster to faster, yeah, energy is convection, because convection didn't need intermediates, like that. The answer is convection.
Okay, thank you.
Yeah.
Mm,
Yeah.
according
What?
according your material, you say the energies cannot be formed and cannot be destroyed. Is that right?
Yeah.
But why the energy cannot be formed and cannot be destroyed? And who is the scientist who said that theory for the first time?
Wait. Um, because energy cannot be created or destroyed, it is always conserved. Energy is continually being transferred from one from to another. I don't know the scientist, because I found this material in book, like that. Next.
Sensi.
Yeah.
Why of energy after long
You.
distance?
I'm sorry. Your signal is not better. I think you can in message
Okay.
where we can use the energy transfer in daily life. Usna question is where we can use the energy transfer in daily life. Meaning like this, you can now the you can now the energy start in the form of strand energy if even you do staging of the catapult, and you can know the conduction, convection, addition in your life, and you can the solar system give a many benefit, like just use solar system you can use all of the electronic, like fan, like computer, like you can charge your phone and other. Next.
Rita Salita,
Yeah.
why solar panels can be said to be energy transfer?
Wait. Because for the first, solar panel is a it depends source of the light of the sun, and the light of the sun source can change to become electrical energy like that.
Thank you.
Me.
Wait. Yeah.
What the advantage and the weakness of electricity energy?
Electricity.
Yeah.
The advantage is you can turn you can open your all of the electrical object, but for the awareness is I think you must spend many money because now electrical energy is very expensive. Like that.
Zalfa,
Yeah. Lot of
insert.
transferring energy over long distance. No. Yeah, long because there are many way like this. Like this. This say for the first is hammer. There is hammer, nail, and piece of wood. And so for the first hammer must use pull that nail of the piece of wood, so can be side the transfer energy. And so long depend of the object. Next.
Vidya,
Yeah, Vidya.
please state the energy conversion principle.
What? Stat.
Please state the energy conversion principle.
This.
Wait.
This or no?
Yes.
What your question? I forget.
Please state the energy. Sebutkan the state energy conversion
Con.
principle.
Wait. Mm, so in physics, like the energy is eternal energy and can be destroyed and always convert, and energy is continually being transferred from one form to another form, like that.
Nisa,
Yeah.
whether potential energy have any kind.
What? Potential energy.
Yeah, have any kind. Potential energy have any kind or no?
I think no. I think just to this is position and conduction. Like that.
Okay.
Me.
Yeah.
Okay. If Indonesia like German with electric energy generated by wind power, if Indonesia make many wind power, is it enough for needs electric in Indonesia? Maybe you can tell me about your opinion about that.
Yeah, I think if Indonesia like a German electricity, the Indonesia will become the what is that? wait. What become the developed countries for the future if Indonesia want to become like German, like that?
Oh, okay. Thank you.
Yeah.
Me.
Yeah.
How many kind of energy? And give me example.
Like many. For the first is like sound energy. The example from sound energy is radio. Can the microphone and the like energy is the lamp, and the visual energy like television, wind energy like windmill. I think just it, which who can I explain for you.
Yeah, thank you.
Yeah, you're welcome. Next. 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 Zalfa. Deska. Next question.
Wait, Safa's question.
Yeah, what?
How does kinetic energy work?
What? Oh.
How does energy kinetic work?
Like this. Like the kinetic energy is any moving body the faster move.
And kinetic energy.
What? What you Rino said. And this in the example of kinetic energy work. For the first is this, in this there is hammer, nail, piece of wood, and for the first hammer is a pulse of the nail into the piece of wood, and that is a become kinetic energy. This is a for example of kinetic energy, like it.
Okay, thank you.
Sama. You are welcome. Next. Next.
Well,
Yeah.
why work change become energy from kinetic?
What?
Why work change become energy from kinetic?
Yeah, wait. Okay. Because like as a hammer pulls a nail into a piece wood, and in there is a transfer of energy from the kinetic energy of the moving hammer to other forms of the energy, like that. Like that, Din. Because kinetic energy of the moving hammer to the other forms of energy. Next. Deska.
Me.
Yeah.
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 Can you mention example from measuring energy transfers?
This. Yeah. This. Wait.
Yeah.
This energy measurements
Okay.
example. Wait.
Mm-mm.
I will. Like if there is what is that? With if there is box beams and the box beam is pull, and in there is energy measurements like that.
Okay, thank you.
Yeah, you are welcome. Any question again? Question. Enough. 17. Okay. I think enough for me, and thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh. Oh iya. Enggak, lebih semenit.
Itu di pause dulu aja. Nggak usah dilanjutkan saja. For the next presentation, you have to pay attention about your display of presentation. You can search on the Google to change the presentation with a good quality. So the participant for when we see when they like that was your presentation. Yeah, to more interest to solve the apa. Dari warnanya itu cuma kayak gitu-gitu terus transfer ada backgroundnya apa itu kalau ini apa ya kayak bahan mentah itu belum di apa namanya belum dipoles. Nulis dari pencet.
Oh iya,
Make your presentation to heavily situation. Don't make your presentation to what's that? Very serious.
Very serius.
Jangan terlalu serius. Dibuat santai tapi masuk. Kalau serius sebenarnya semangat. Ada sandarannya juga ada apa-apa.
Assalamualaikum warahmatullahi wabarakatuh. Now I will explain basic about momentum. Momentum is a useful quality to consider when bodies are involved in collision and explosion. Collision and explosion are things which collision other things. This be found by Sir Isaac Newton. He is physicist, mathematician, astronomer, natural philosopher, chemist, and theologian. He was followers of a highly influential heliocentric and scientific movement throughout history. even said to be the father of classical physics. Example momentum in daily life is two moving truck, then call it, and each marble would have momentum, and the amount of momentum between the two marbles after and before the collision was the same. And when we go to buy car, stop suddenly, then we get pushed forward by the steady amount of momentum. Formula of momentum is P equal to M times F times F. P is momentum, M is mass is mass kilogram, and F is velocity, mass meter per second. Momentum depend velocity and mass. So greater than velocity, greater also collision. For example, mass of thing is 5 kilogram with velocity is 10 meter per second. How much momentum? Formula is momentum is mass 5 kilogram times velocity is 10 meter per second. So this equal to 50 kilogram meter per second. Next, there are 5 laws in momentum. There are conservation of momentum, explosion, rocket and jet, force and momentum, and impulse. Conservation of momentum is when two or more bodies act on one another, as in a collision, the total momentum of the bodies remain constant, provide no external force. This is principle of conservation of momentum. An experiment like those in the participant work section show that it is true for all types of collision. The formula of conservation of momentum is ma times va plus mb times vb is equal to ma times va1 plus mb times vb1, and this before collision and this after collision. For example, a truck mass 60 kilogram moving with velocity 3 meter per second collides with truck stationary mass 30 kilogram. The two move off together with same velocity, which we can find as follow. This is picture from this question. So the answer is the formula is mass is 60 kilogram times velocity is 3 meter per second this plus the 30 kilogram times 0 meter per second. Why the 0? This because this at rest and equal to the after is 60 kilogram time 30 kilogram times V. V is not yet now. So this 60 kilogram times 3 meter per second plus 30 kilogram is equal to 180 kilogram mass per second is equal to 60 kilogram times 30 kilogram is 90 kilogram times V. So we must find V. V is equal to 180 kilogram mass meter per second divided where is divided 60 kilogram. So velocity is 2 meter per second. Conservation of momentum allow a price to even collision of object, interaction to object, explosive event, upside down event running rocket and jet. Example application conservation of momentum in daily life is principle of rocket launch. The amount of momentum generated by the thrust of the fuel is the same as the momentum of rocket launch. And people jump from boat. The momentum of the boat returning backward is the same as the momentum of the person jumping forward. Next, explosion. Explosion is converted in explosion such as occurs when a rifle is fired. Before firing, the total momentum is 0 since both rifle and bullet are at rest. During the firing, the rifle and bullet receive equal but opposite amount of momentum, so that the total momentum after firing is 0. Momentum, like velocity, is a vector since it has both magnitude and direction. Vector cannot be added by ordinary addition unless they arc in the same direction. If they arc in exactly opposite direction, such as east and west, the small strike from the crater, or if the same, they cancel out. For example, if a rifle fires a bolt of mass 0.01 kilogram with velocity of 300 meter per second, forward momentum of bolt is 0.01 kilogram times 300 meter per second is equal to 3 kilogram meter per second. If the rifle has mass m, it recoiled with a velocity v such that mv is equal to 3 kilogram mass per second. This taking m is 6 kilogram. This up to you. Give v is equal to 3 divided 6. So divided 6 meter per second, so equal to 0.5 meter per second. Next, rocket and jet. If you release an inflated balloon with its neck open, it fills off in the opposite direction to that of the escaping air. The air, like this picture, the air has momentum to the left and the balloon movement to the right with equal momentum. This is the principle of rocket and jet engine. In both, a high velocity stream of hot gas is produced by burning fuel and leaves an exhaust with large momentum. The rocket or jet engine itself acquires an equal forward momentum. Space rockets carry their own oxygen supply. Jet engine use the surrounding. So this picture balloon air to the left and balloon uh, to the right. Force and momentum. If steady force, if action on a body of mass m increases its velocity from u to v in times t, the acceleration is given by a equal to v minus u divided t from v equal to u times a t. Substitution for in f equal to ma. F equal to m v minus u divided t. So mv minus same mv minus mu divided t. Therefore, force change of momentum divided time is equal to rate of change of momentum. This is another version Newton's second law for same problem. It's more useful than V equal to ma. There are V t equal to mv minus mu, where mv is the final momentum, the initial momentum, and ft is called the impulse. Next, impulse. Impulse is the good kick of tennis player follow through with a bat or racket when striking the ball. The force fluid, then for a longer time, the impulse greater, and so also in the gain of momentum and velocity, or impulse in change in momentum. Formula of impulse is A equal to delta P is equal to P1 minus P. So P1 is M times V1, P is M times V. This minus, for example, there are ball this mass 2 kilogram and throw in the well with velocity 5 meter per second, and this mental V1 equal to 2 meter per second. The answer is A equal to M V1 minus V. Is equal to M is 2 kilogram, F1 is 5 meter per second minus if F1 is 2 meter per second is minus V is 5 meter per second. This 2 kilogram, this 2 minus this because to the left, so this minus so minus 2 minus 5 is equal to minus 7 meter per second. Then 2 kilogram times minus 7 is minus 14 kilogram mass per second. Yeah, this minus because collision to the left, and impulse if example impulse in daily life is when kick ball and basketball goes over 3, playing badminton when hitting a volleyball. Then for impulse for sport is when we want to stop moving ball, such as a skate ball. However, its momentum has to be reduced to 0, and impulse is then required in in the form of opposing force acting for a certain time. Well, any number of combination of force and time will give a particular impulse. The string can be removed from the chart by throwing back the hand, and as the ball is caught, a smaller efference force is then applied for a long time. The use of sand give a softer landing for a long jump, as a smaller stopping force is applied over a longer time. In a car's start, the car momentum is reduced to zero in very short time. If the time of impact can be extended by using combustion, an extensible seat belt, the average force need to stop the car is reduced to the injury to passenger should also be less. And there are also collision and momentum. If a collection of momentum is practical work, so an arrangement which can be used to find the velocity of valley before and after a collision. If a trolley of length per takes time to pass through a photograph, its velocity to photographs are need placed each set of the collision point to find the velocity before and after the collision. Set them up so that they will record the time take for the passage of a troll. A sticker type timer of motion sensor placed at the top end of the runway could be used in terms of photographs if preferred. Attack a strip of velcro to each troll so that they stick to each other on college and compensate the runway for friction. Place one troll at rest halfway down the runway and another the top. Give the top troll a push. It will move forward with uniform velocity and should hit the second trolley so that they self on as one, using the time record by the photograph timer. Calculate the velocity of the moving trolley before and collision and the common velocity of both trolley after the collision is like that.
And then after you give your presentation, you can give the example and you do together with
Hmm. Lah.
at least 1 hour.
Hmm.
Yeah, I mean for your from your presentation, you do 1 or 2 or 3 example and you do
Yeah, yeah.
together, discuss together about it.
For I will give you question for impulse. If the ball mass 5 kilo mass 5 mass 5 kilogram and the with velocity is 10 meter per second and collision with for example tree and mental 2 meter per second. So how much the impulse? Who can answer this? Halo. Maybe Budi can answer this. Answer. Bud. Oh, Zalfa maybe. Or Sakif. Bud. Later you not give me question. Or Ratna, maybe you can answer. Rat,
Yeah,
you can answer this.
I don't understand.
Uh,
The rumus is
Dening rumusnya hilang sih nang kene. The rumus is mass times V1 minus V2 like this. Mass
repeat. Mass
equal to impulse is equal to mass times V1 minus V. V1 is
velocity. Yeah.
This.
Huh?
V1 is 2.
Oh yeah. Yeah. 5 times V1 2 ya.
What?
V1
is 2.
Collision. Oh yeah. And V velocity.
Yes.
V1 2 minus is minus 8 M 5 minus 40.
Minus 40. I also don't know.
Okay.
Maybe right.
Okay.
Mass is 5 kilogram and times V1 is 2 meter per second minus F is 10 meter per second. So 5 kilogram.
40 ya, 40.
And because this is mental, this become minus. Mental, this is minus. So minus 2 minus 10 is equal to minus 12.
Oh.
Yeah, is equal to 5 kilogram times minus 12.
60.
Yeah.
Yeah. Thank you.
Yeah. Minus 50. Plus times minus. So minus.
Loh kok 40 sih, minus 40. 60.
Oh yeah. Nah.
Okay, enough. Thank you.
Astagfirullah.
After this, I not give you question, yeah.
Yes, not.
Thank you.
Yeah. I will. You understand this or no? Do you understand this or no?
No, of course no.
Oh yeah. Lu.
Let's begin together to resolve this question together.
Yeah, I will repeat. Let's discuss together. Yeah.
Yes.
Yes. Formula conservation of momentum is mass A times VA plus MB times VB is equal to MA times VA 1 plus MB times VB to the power of 1.
What the meaning of MB variable and stress etc. MB variable, VA variable,
MB variable.
You can explain to them what's the meaning of that variable one by one. So we'll understand what you're speaking.
This just tanda mark this before not there are one, so and after is there are one. So
I mean, what's the meaning of
MA. M is mass, A is acceleration. VA is velocity acceleration. And MB is mass. Acceleration. So if we do this, this MA is 60 kilogram, and VA velocity is 3 meter per second plus M plus MB. MB is 30 kilogram and FB is 0. This because at rest is equal to 60 kilogram times 30 kilogram plus 30 kilogram times V. This because not yet now. So this V. So 60 kilogram times times 3 meter per second plus 30 kilogram is equal to 180 kilogram meter per second. Is equal to 60 kilogram plus 30 kilogram is equal to 90 kilogram times V. So we will found V. V is 180 kilogram meter per second divided 90 kilogram. So V equal to 2 meter per second. I will explain rocket and jet. Maybe you don't understand. This balloon is to the right and air to the left. This because collision. If you release an inflated balloon with neck open, its fell off in opposite direction to that of the escaping air. Like this, the air has momentum. The air is to the left and the balloon to the right with equal momentum. This is principle of rocket and jet. In both a high velocity stream of hot gas is produced by burning fuel and leave the exhaust with large momentum. The rocket or jet itself acquires an equal forward momentum. Space rocket carry their own oxygen supply. Jet engine use the surrounding air. This for example, of force and momentum. If force and momentum, if force is equal to change of momentum. Change of momentum is, for example, 10 and time is time is 2 meter per second. So rate of range of momentum is 5 meter per second. This is force. For momentum, I will repeat. Formula of momentum is mass times velocity. Mass is 5 kilogram times 10 meter per second is equal to 550 kilogram meter per second. This is mass and this velocity. Momentum is mass kilogram mass per meter per second. For this, to know MV is 3 kilogram meter per second. Taking mass is this up to you. 6 kilogram give velocity is equal to 3 divided 6. So this 6. This 3 divided 6 meter per second is equal to 0.5 meter per second. For this formula of impulse is mass times V1 minus V. For example, mass is 5 kilogram times V1 is 2. This mental become minus 2 meter per second is minus V is 10 meter per second. So 5 kilogram minus 2 meter per second minus 10 meter per second is 12 meter per second. So 5 kilogram times minus 12 meter per second is equal to minus 60 kilogram meter per second. this for momentum of bolt is bolt of 0.01 kilogram times velocity is 300 meter per second. So 0.01 kilogram times 300 meter per second is equal to 3 kilogram meter per second. Explosions is like velocity is vectors since it has both magnitude and direction. Vector cannot be added by ordinary addition unless they act in the same direction. If they act in exactly opposite direction, such as east and west, the smaller subtracts from the greater, or if the same, they will cancel out. Momentum is convert conser- convert in an explosion such as occurs when a rifle is fired before firing. The total momentum is zero since both rifle and bolt are at rest during the firing. The rifle and bolt retrieve equal but opposite amount of momentum so that the total momentum after firing is zero. Uh, mo- terus, momentum in daily life is example momentum in daily life is two moving thrown then call it an each marble would have momentum and the amount of momentum between the two marbles after the and before the collision was the same. And when we go to by car stops that suddenly, then we get pushed forward by the steady amount of momentum. This conservation of momentum formula this before and this after collision. For example, this. So yes, like this. 60 kilogram from ME and 3 meter per second is from VA plus MB is 30 kilogram and FB is 0 because at rest is equal to 60 kilogram. This is ME1 and this ME2. velocity is not now. So 60 kilogram times 3 meter per second plus 30 kilogram is equal to 180 kilogram meter per second. And this 60 kilogram times 30 kilogram is 90 kilogram. So for found velocity is 180 kilogram divided divided 90 kilogram. So V is 2 meter per second. Collision is divided by 3. Correlation are not flawless. Correlation partially result and correlation perfect result. There are relationship is impulse and momentum. Theory impulse said that impulse which work an object same with change momentum from this object. The conservation of momentum state that within same problem domain the amount of momentum remain constant. Momentum is neither created nor destroyed, but only changed through the action of force as described by Newton's law of motion. And this before launch the rocket is at rest on the launch pad, so its momentum zero. When the rocket engine fires, burning gases are expelled from the back of the rocket. I think enough. Any question?
Richard
Me,
Lai.
me.
Ya, Rizal.
Yeah.
How much the power explosive of a nuclear bomb and speed of nuclear bomb?
Nuclear burn.
Will relate with your material.
Repeat, Rizal.
How much the power explosive on nuclear bomb and speed of nuclear bomb?
Nuclear. If you the rocket or jet itself acquires an equal forward momentum. Space rockets carry their own oxygen supply. Jet engine use the surrounding air. Yeah, next.
Me.
Nancy.
Me.
Nancy.
Oi.
Aku naik.
Naik message. Chat.
Naik.
Chan. Yeah.
In chat.
Aku naik.
Hi, Chancy first ya.
Yeah. Chancy.
The difference between momentum and impulse.
The momentum change of an object is the mass times velocity, and the impulse equal the momentum change.
Okay, thank you, Nai.
Naik. Aku naik. Naik.
Yeah, Budi.
What causes momentum?
What?
What causes momentum?
Cause. What is cause?
Apa yang menyebabkan momentum?
Collision and explosion. Yeah.
Okay.
Next.
Lita.
Yeah.
Can you tell me the type of collision?
Collision.
Yes.
type is collision is there are three. Collision are not flawless. Collision partially resilient. Collision perfect relation.
Okay, thank you. Now,
Me,
question from Vidya in chat.
wait.
Yeah,
Me,
yeah.
check.
Yeah.
What kind of momentum?
What kind of momentum? Uh, Momentum useful quantity to consider when bodies are involved in collision and explosion. Next.
Sakifa.
Yeah.
Is there tools or stuff that using rocket and jet concept, but other than rocket?
What?
Is there some stuff or tool that using rocket and jet concept, but other than rocket?
Nah, Husna question in message ya.
Yeah. Uh, if if relief in a rocket, height and velocity stream of hot gas in produced by running fuel and leave the exhaust with large momentum. Vidya state the type of collision on momentum. The type of collision on momentum type is collision are not flawless, collision partially racial, and collision perfect racial. Husna, what is the momentum of a rocket before flight? Before flight, the rocket is at rest on the launch pad, so its momentum zero. When the rocket engine fires, burning gases are expelled from the back of the rocket.
Zalfa,
Yeah.
is there is relationship between momentum and impulse or no?
Relationship from theory impulse side that impulse which work in object same with change momentum from this object. Next.
Nisa.
You.
Whether impulse and momentum are affect the speed of kick the ball.
Effect. Effect is the effect is collision of object, interaction to object, explosive event, upside down event, running rocket and jet.
Okay. Some fast question in chat.
Yeah. Can because cannot because just to think. Next. Enough.
Me first.
Oi.
Lukman.
What is the biggest invention which formed from momentum formula?
Repeat.
What is the biggest invention which made from momentum formula?
Yeah. To know collision and explosion. Next.
Test that.
Enough.
Me.
Yeah.
Okay. Maybe you can tell me two activity which is in this activity there is momentum.
Yeah. What?
You can tell me two activity which is in this activity there is momentum.
Activity momentum is two moving truck, then call it an edge marble would have momentum, and the amount of momentum between two marbles after and before the collision was the same. And when we go to buy car stop suddenly, then we get pushed forward by the steady amount of momentum.
Okay, thank you.
Yeah. Next.
Nai,
Yeah.
what the concept or application of momentum in our daily life?
What? Repeat.
What the concept to application of momentum in our daily life?
Concept of momentum in daily life. Concept. Concept momentum is concept momentum is daily life. For example, the amount of momentum generated by the course of the fuel is the same as the momentum of rocket launch. And when two or more bodies act on one another as in a collision, the total momentum of the body remains constant, provided no external force acts. Here. Next. Enough. Sabes. Enough. Deska ya.
Me.
You.
Can you mention? Wait. Can you mention example from conservation of momentum? Oh yeah, thank you.
Mention of conservation of momentum.
Yeah.
Mention siapa mention? Hah? Apa sih? What is the meaning of mention?
Oh.
Mention. Sebutkan. Oh. Sebutkan. Example of conservation of momentum. People jump from boat. The momentum of the boat returning backward is the same as the momentum of the person jumping forward. Yeah. Next.
Me.
Yeah.
Who invented the concept of momentum?
Sir Isaac Newton.
Okay, thank you.
Yeah. Enough. Enough ya. Yeah, thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh. Lemes.
jam loh. Ayolah. Wih, gak disitik guys yang join. Anak teladan.